Hello, in this example, in this tutorial, I would like to implement a algorithm called DLA, which stands for Diffusion-Limited Aggregation. It's one type of algorithm to simulate a growth of a dust or lightning or trees, and I would like to implement that in Houdini, and in this case in 2D, since it's a bit easier than 3D. So let me try it. Okay, let me explain the algorithm in Sketch a little bit. So first of all, you set a basic point, the starting points, and what you need to do is that you make a random walker around this base points like this, and first you need to calculate or get the vectors from the base point to each points. And if you have multiple base points like these and a random walker, random points, random base points stands like this, first you need to get for each red points, the random points, first you need to find the closest base points. So make a line like this. Something like this. And let those random points placed on the specific radius from the base points, somewhere around here. And if the closed points on the project points are too close, it's a bit problematic since you're gonna have like too many branches from base points. So use some node like fuse to delete some points based on some limitation, maybe the distance, the radius you set. So use that radius to remove the two closed point. Then after that, you'll get something like this. And after that, you can make a line like this. And after doing this, you can make another random points on the space and calculate the closest distance between the base points. Right now you have 4 points for each areas, so total like 12. And you calculate the closest distance. Some might go on the outbound, some goes to the first points, something like this. And since the outer points have a better chance to stick with the random points, the result you'll get is more likely a branch-like pattern, something like this. And that's what I'm gonna make in this tutorial. Okay, so let's close this and let's start doing this. First, you make a geometry as always and get into it and delete this. First, let's make a null and let's color this blue and name this controller to have all the parameter you want to control. Let's make some parameters here. First of all, let's have the branch length, which will be the length of each line, each branch, and let it be float, range from 0 to maybe 1. And another a parameter, I will name it diffusion range. With this parameter, I would like to define how far this random points will be generated from the base points. Let it be like 0 to 10, it's fine. Plus, maybe I would make another parameter. Let's call this density. For this parameter, I would like to set the density of the random points for each iterations. So I will make it from 0 to 10 again, apply, and let's set some value here. Like for the branch lengths, I'll set to 0.05, diffusion range to 2.5, and the density to 2. But I could change it later based on the results. Okay, now let's make a grid to define the base points. Okay, as a base size, let's set it to 15 by 15. And let me show the edges. Okay, and I would use the scatter, and for this example maybe like the number of 3 is fine, so 3 points to be the basic points to start. Could be any number, but I think it's better like 3 to see the result. Okay, now I would need to set a group for each base points in order to use it later. So I would like to first make a group called seed, which stands for the base points where the branch starts, and set it to point and base group to enable. Okay, so let's make another group, and let's name this next one, which will be the random points that will be scattered around the base points. And I would set the base group to disable because these are the base points. Let's look at the geometry spreadsheet. Okay, forgot to set it to point. Okay, if I look at the geometry spreadsheet, yeah, right now all the points are set to seed, and the next is set to 0, so that's fine for now. And also let's Let's make some attributes for the points. For several purposes. First of all, I would like to color the branch, let's say the growth, lightning or trees, to be colored based on the branch index. How far from the center points, the base points, right here at this position. So in order to do that, I have to store some branch index for each point. So let me make that first. So I'll name it branch index. Let it be point, and the default to be 0 is fine. Okay, and let's make another attribute as well. Let's name this a max branch index. And for this one, I don't need to set it to each point because this is the max and it doesn't change by the points, so I'll set the detail. Okay. And also for each point you need to have the information which point to be connected in order to make a line. So I need to make another attribute, and now let me call this connection point, and let it be integers since this will be the index number. This will be the integer as well. I mean, everything will be integers since everything is an index. And for the connection point, it will look for the previous points where it has connected. So the random points, the new random points, if the random points will be connected to the base point, and if the base point's index is 0, then this random point will have a 0 as a connection point. But for base point itself, it's not connected to anything as initially, so it needs to have a -1 as an initial value. So if the value is -1, it wouldn't connect to anything. Okay, so I think the setup is done in order to start using the solver calculation. So let's do that. Before doing that, maybe I should make the point size a bit larger. Where do I do that? This one, I think. Okay. And let's make a solver. Get into it. And let's start making. Okay, first of all, we have to make a random points around the base points, so let's use a wrangle, point wrangle, to do that. And well, since I don't need to do per points, I think I will do using detail. And let's import some variables and parameters from the controller. So first of all, you need to get a branch length, and from the CHF obj go1 controller, And what was the name? Branch lengths. Okay, the next one, diffusion range. obj go1 controller diffusion range. Okay, another one, density chf obj go1 controller density. Okay, let's check if there's a spell mistake or anything. I think it's fine. Well, let me try. Branch lengths f diffusion range density. Let's check if I imported all the parameter correctly. And yeah, I think I got it. Okay. Now, first of all, what it will be the best way to scatter the points around the base points? Maybe I could get the center points of the or average point of these points somewhere around here and make a big circle that covers the points, and from this circle I can make a scatter points. So let's do that first. So what I need first is the center point, and I can get that using the get bbox a center, bounding box center from the 0 input. And also let's get a max point of the get bounding box. So that could be this or this or this. Maybe this one. Well, it's supposed to make a bounding box like this, and if I tell to get the get box max, then you will have the points on the max position, and you can use that to assume that that's the maximum radius of this bounding box. So finally I could set the radius of the circle that I'm gonna use to scatter the points. First you get the max minus center, which will be the radius of the bounding box, plus the branch lengths to make a little bit of margin or padding. Now so in order to set how many points to be generated, I would like to set the number of the points based on the area of the circle itself. So area of the bounding, the circle that covers the bounding box of the points. So what I could do is that I could make a number, and the area could be calculated as radius times pi times, and that's it. But I could then make a density I could use a density variable to set the density by yourself, control the density of the points. But it's always related to the radius of the bounding box. So if the lightning or trees grows up, the radius of the circle will grows up as well, which makes the number of the populated random points will be increased as well. Okay, so let's use the for loop from int to number, and first let's make a vector2 and name it direction, and what I want to do is from the center points, which should be somewhere around here, I would make a random vectors that's heading on to the circle, and use that random vectors to multiply by the radius to make a or let's draw this out. Okay, so so each base points, by each base points you will get the center points, and set the radius of the circle that you want to make a scatter points. And by using the node called, the function in the vex called sample circle uniform, you will get the vector, the random vectors. Doesn't always be random, but you can use the random value to make a random vector that's on the circle, which is the length of a 1, I think, or maybe not. And or if it's not 1, you can normalize it. And after that, use the random value to multiply the lengths of the vectors within from 0 to the radius. And as a result, you will get a random scatter points inside the circle, like this. Okay. So the thing you would need is the normalized sample circle uniform, and I want to make the direction to be random, so I would use the m random function. And let's make a vector called new position, which will be the center plus set, and I would use the direction. Since this is the vector 2, I would set the x to be on the first parameter, and second will be 0, and the third one to be direction y, times and random to make the length random, and times radius times diffusion range. This is the variable that I set to make the radius extendable. So if the diffusion range is 1, the radius is equals to the radius of the bounding box plus immersion, a little bit of immersion. But by multiplying it by diffusion range, I could extend the radius to make the circle bigger. So that's what I'm doing here. Okay, next. Let's make a new point with this information. New position. So as a result, you will get a points on the circle range, and since it's using the random, it's gonna change the value by each frame. Okay, and let's set the group for these points, and using the set point group. And for the seed, this is not going to be the seed yet, since it's on the random position. So I will set the seed new point to be 0 and set point group, and the next to be 1. Okay. Now if I look at the geometry spreadsheet, you would have a point which have the group next on for a newly created one. Okay. Let's name it create random points. And let's make another point wrangle. And for this one, I wanna use it to calculate each point. So the point is ran over point is fine, but I only want to run through the points on the random position. So I would set the group filter to be next. And let's import the branch length variable right here as well. So let's copy this. Oops. And paste it here. And first you need to get the closest point or nearest point from the random points to the base points. So you want to know which base point is the closest one. So you can use the neighbor you can use the near point from the seed group compared with the point itself, and you will get the index of the closest base points. So you want to know the position of that point as well. So let's make a variable called neighbor pos equals to 0.0 p and neighbor pt. And finally, let's get the index of the branch index. of the point. Of the neighbor point, well, which in the initial calculation, which will be the base point, and this will be -1, I think. Okay. Next, let's make a vector called new position to move each random point close to the closest base points with the range of the branch lengths. So first you start from the neighbor pos, which will be the position of the closest base points, plus normalize p minus neighbor pos times branch lengths. And let's make a new point. Add point, new position, or maybe I could just set point attribute, set point attriv, seed, set point attribute, and the or I could just, oh yeah, I could just say p equal new position, which will move all the points to the closest base points, like this. Okay. And set the point group of the point, the seed, to be pt_num to be 1. Let all the points to be set to seed. And set point group 0 next, pt_num to be 0. And also set the point attriv connection point, new point to neighbor point. Not the new point, pt_num. Okay. And finally, you want to set the branch index as well. That's for the coloring purposes. So let's make a next neighbor branch index to be neighbor branch index +1, since it's gonna be the next branch. So use that to set point attribute, set the branch index to the pt_num, and next let me just copy this. Okay, and also let's get the max branch index from the detail attribute, and compare with the next neighbor branch index, max branch index. And if the next branch index is bigger than max branch index, then update the branch index, max branch index on the detail attributes. Set detail attribute 0 max branch index. Okay. And let's look at the, so the connection point is updated and everything becomes seed here. And if I look at the detail, the max branches is 1. So I guess the first one is 0 and the second one, the second branch here is 1. And okay, now the problem is right now the points together is too close to each other, so I have to delete it somehow. And you can just use a simple fuse for this purposes. And for the parameters, let's go to the controller and copy the branch lengths, copy parameter, and go to the fuse, and the option consolidate is fine. Set the distance to base the parameter from the branch lengths, and check to keep unused points on, and let the group to be seed. And I'm not still seeing the stuff. Oh, wait a minute. Let me go back to the here and let's go in here. Okay. Now you can see that the number of points are reduced to the maximum, the length of the branch. Okay. Now that's all I want. Let me check the parameter here, the variables here. Okay. The branch index 0 and 1. Okay. Now I think this is fine with the solver. So let's go on top, go up, and let's play. And now, yeah, it's already making a lightning-like or tree-like aggregation with the points. And if you change the parameter here, for example, by changing the density bigger, you could have more dense network, or you can set the diffusion range to be bigger to make it a little bit sparse, more branch-like, or make it smaller to make it more to make more points inside the structures. I like the first setup, so I would go with this one for this example, but you can try out many parameters here. You can also change the branch length as well. And now, right now you only have points, so I would like to make a curve or line in the between points so that it could be much easier to show the result. So let's make a point wrangle here. Oops. A point wrangle connected to the first input, and let's make a, first of all, let's get the max branch index from the detail attribute. And also get the point branch index. Okay, and first of all, I would like to make the color information for each point. So let's make attribute color and make a branch index divided by max branch index. As a result, if you look at the geometry spreadsheet, you would have a number from 0 to 1. So simply I have normalized the information branch index using the max branch index. Okay, now I could color the point at this point. And let's go to the parameter and let's set the color type to ramp from attribute and use the col that I have just used. And from here I could set the base points color, the color that's close to the base points. Maybe make this orange and make the edge color to be green. Yeah, looks more like a slime mold. Okay, now let's make a line, polyline from these points. Now if I look at the point attribute, I have an information called connection point, which tells you which point to be connected to make a line. So I could just use that to make a polyline. So let's make a point wrangle and get the connection point first. Wait a minute. I think I can just... I could just do like this and make a polyline. Polyline with the connection point and the PT num. Right, like this. And it also reserves the colors and looks great. Okay. Now this is kind of it. You can now make a... I just reopened the file. Somehow it crashed. I think it's because I think I know what's wrong. In the solver, I was outputting diffuse as a final result, but then there might be a chance that you would have a geometry with the next still exist as a result. So just to make sure that there's gonna be no points grouped in next, I will delete all the points which is on the next group. So, and let this delete to be the final on the solver, and let's recalculate it. And seems okay now. Last time without the delete it just crashed around 230 something, so about right now it looks okay, so I'll go with this one. Okay, and I'm almost done with this. After this, maybe if you want to make a pipe around if you want to thicken the lines, then I guess you can use the VDB probably. So in order to do that, you can resample the line and use the branch lengths and paste it on the lengths here. And if you look at the points, you have additional 1 point here, so that might be okay. And let's also fuse this to make sure there's no overlapped point. Okay, and use the BDB from particle. Make the radius like 0.05 or something, and the resolution to be 0.025 or something. Yeah, maybe the radius to be a little bit thinner, like, oops, I guess this is the minimum I could go. Okay, and convert the VDV to polygon. Okay, and if I want to color this, then I think I can use the attribute transfer. And what I want to color is the geometry, the mesh, and what I want to transfer is the color on the point, and that is set it here. I can use this point information, so I'll put it here. And I have the mesh with the color transferred. And I think that's it. Let me try to animate this. Let's cache this. And let's animate this. Okay, almost done. Yeah. And I think I've cached all the frames. So now let's make a flipbook. Maybe around here. And make a flipbook. Start. And here it goes. This is a result using the diffusion-limited aggregation. Looks like the growth of a dust or lightning or tree or slime mold. Yeah, and the same algorithm could be used for 3D, or it could also be used to run through the specific surfaces as well by tweaking some algorithm inside the solver. Okay, that's it. Thank you.